Everything you see right now might be a projection, not a metaphor, not science fiction, a literal statement supported by some of the deepest mathematics we have. According to modern physics, the universe may not be three-dimensional at its core. Space, depth, and distance could be illusions. Reality itself may be written on a surface far away, like a cosmic hard drive encoding everything you are. This idea did not come from philosophy. It came from black holes. In the 1970s, physicists ran into a terrifying problem. Black holes were not just swallowing matter. They were destroying information. When something falls into a black hole, it seems to vanish forever. Its particles, its structure, its history. But the laws of quantum mechanics say information can never be destroyed, ever. If it is lost, physics breaks. This contradiction became known as the black hole information paradox, and it threatened the foundations of reality. Then came a radical realization. If information is not destroyed, it must be stored. But where could a black hole store the information of everything it eats? The answer was shocking. Not inside the black hole, on its surface. Physicist Jacob Bekenstein discovered that a black hole's entropy is proportional not to its volume, but to the area of its event horizon. Stephen Hawking later confirmed it mathematically. This meant that all the information about what falls in is encoded on a two-dimensional boundary. That single result changed everything. If a black hole can encode a three-dimensional interior on a two-dimensional surface, then maybe the entire universe works the same way. Maybe all of space is emergent. Maybe reality itself is a hologram. This idea became known as the Holographic Principle. In simple terms, it says that everything happening inside a region of space can be fully described by information written on its boundary. Just like a hologram, where a flat surface produces a three-dimensional image, the universe may project depth from something fundamentally flat. And here is where it gets unsettling. In the late 1990s, physicist Juan Maldacena showed that a universe with gravity can be mathematically equivalent to a universe without gravity that exists on its boundary. This is known as the ADS/CFT correspondence. Two completely different realities, one with space, time, and gravity, one without them. Yet they describe the same physics. That means space itself might not be fundamental. Distance could be an illusion created by information relationships. Time could emerge from quantum interactions. Gravity might not be a force, but a side effect of how information is organized. Your location, your movement, your body, all of it may be a pattern in a deeper informational structure. This is not fringe science. These ideas are actively studied in quantum gravity, string theory, and quantum information theory. Researchers are discovering that space-time geometry can be reconstructed from quantum entanglement. When particles are entangled, their information links appear to generate the fabric of space between them. Less entanglement means more distance. More entanglement means closer proximity. Space may be built from information connections. And if that is true, then the universe is not made of things. It is made of data. Which leads to a disturbing question. If you are information, what happens when you die? In classical thinking, death is destruction. The body fails. The brain stops. The person is gone. But information cannot be destroyed. Quantum laws forbid it. At best, it can be scrambled, transformed, spread out. So where does your information go? If the universe is holographic, then everything you are may be encoded somewhere on a cosmic boundary. Your past, your thoughts, your physical structure, not preserved as a conscious being, but as a pattern that never fully disappears. This does not mean immortality. It means irreversibility is an illusion. It means the universe never forgets. It only rearranges. Every interaction you have ever had leaves a trace. Every particle you have touched becomes entangled with others. The ripple spreads outward, encoded deeper into the structure of reality itself. Even now, your existence is being written somewhere you will never see. And the most unsettling part is this. If reality is a hologram, then the universe you experience is not the base layer. You are not living in the source code. You are living in the rendered output, which raises a final question that physics is only beginning to ask. If the universe is information on a surface, what is that surface attached to? If that surface exists, it is not nearby. According to holographic models, the information describing our entire observable universe could be encoded on a boundary billions of light years away. Not at the edge of space, but at the edge of what we can ever observe. A cosmic horizon, a limit written into reality itself. This boundary is not a wall. It is a mathematical surface, a place where information lives without space or time as we know them. And this creates a strange inversion. In everyday life, we think surfaces depend on interiors. A screen depends on what is inside the computer. But in holographic physics, the interior depends on the surface. The three-dimensional universe emerges from two-dimensional information, not the other way around, which means the deepest layer of reality may not have space at all. Physicists have found something even stranger. When they calculate the maximum amount of information that can exist in a region of space, it does not scale with volume. It scales with area. Double the surface area, and you double the information capacity. Add more depth, and nothing changes. This limit is known as the Bekenstein bound. It tells us that the universe has a maximum resolution. There is a finite number of bits that can describe everything inside any region. Reality is not infinitely detailed. It is compressed. That compression is not optional. It is enforced by the laws of physics. And compression always means loss. Not loss of information in the absolute sense, but loss of accessibility. Details are not destroyed. They are smeared across the boundary in ways that cannot be perfectly reconstructed from inside. This may explain why time feels irreversible. At the fundamental level, the equations of physics are time-symmetric. They work the same forward and backward. Yet your life only moves one way. Memory accumulates. Entropy increases. The past never returns. In holographic models, time's arrow emerges from how information flows toward the boundary. As information spreads and entangles, it becomes harder to reverse. The universe does not forget because it wants to. It forgets because it must compress. You experience this as time, and that leads to an even deeper implication. If space-time emerges from entanglement, then breaking entanglement can break space itself. In theory, removing quantum links would cause regions of space to tear apart. Distance would grow. Geometry would collapse. Space is not held together by matter. It is held together by information. This is not speculation alone. In simulations, physicists have reconstructed curved spacetime using nothing but quantum bits and entanglement rules. No coordinates, no background space. Geometry emerges automatically. It means the universe behaves less like a place and more like a computation, but not a digital simulation running on a computer. Something far stranger, a self-encoding system where the boundary defines the rules and the interior plays them out. So, can we test this? Not directly. The boundary is beyond reach, but holographic ideas leave fingerprints, subtle limits on information density, patterns in quantum noise, relationships between gravity and entropy that should not exist if space were fundamental. Some physicists believe gravitational waves and black hole mergers may carry clues. Others look for constraints in quantum chaos and thermal behavior. These are not experiments you run in a lab. They are cosmic scale consistency checks. And so far, the math, not fundamental. You feel like a solid object moving through space. But at the deepest level, you are closer to a ripple moving across a surface you will never touch. And that raises a final unsettling thought. If the universe is encoded on a boundary, and everything inside is emergent, then the question is no longer what the universe is made of. Physics does not answer that question, not because it is forbidden, but because the equations stop caring. The mathematics describes how information behaves, not who experiences it. There is no observer written into the boundary, only relationships, only rules. And that may be the most unsettling result of all. In a holographic universe, observation does not create reality. Reality exists as information whether it is watched or not. Measurement does not summon the universe into being. It only reveals how deeply entangled you already are with it. This removes a comforting idea. You are not special because you observe the universe. You are special because you are part of the computation. Every observation you make is an interaction. Every interaction spreads information. And once spread, it cannot be gathered back perfectly. That is why certainty fades. That is why the future feels open and the past feels fixed. Quantum decoherence explains this at the smallest scales. Entanglement with the environment destroys clean quantum states. In holographic thinking, this same process may operate at cosmic scales, turning pure information into classical reality. The universe looks solid because too much information has already leaked, which means the early universe was different. Near the beginning of time, information was tightly packed. Entanglement was extreme. Space-time itself may not have existed yet. There was no distance, no direction, no before and after, just a dense web of correlations. As the universe expanded, information stretched, entanglement diluted, space unfolded. Expansion may not be space growing into nothing. It may be information rearranging itself across a larger surface. This reframes the Big Bang, not as an explosion in space, but as the rapid emergence of space from something deeper, a transition from pure information to geometry. And if that transition happened once, it could happen again. Some physicists believe black holes are time-reversed Big Bangs, regions where space collapses back into information, where geometry dissolves and the boundary takes over. From the inside, it looks like destruction. From the outside, it looks like storage. Nothing escapes a black hole except information written onto its horizon. And that brings us back to you. If information is conserved, then everything you do contributes to the state of the universe forever, not as memory, not as consciousness, but as irreversible influence. Your existence changes the boundary conditions of reality. Even now, photons reflected from your face are traveling outward, carrying information about you into space. Some will hit dust. Some will hit stars. Some will escape beyond any future observer, but none will vanish. The universe keeps the receipt. This does not mean your identity survives. It means your impact cannot be erased, which forces a final reframing. Maybe the holographic universe is not about illusion. Maybe it is about limitation. You see 3 dimensions because that is all the information you can access. You experience time because compression is written, and whether we were ever meant to see it.